Hello. In this video, we'll be looking at the lateral area and the surface area of a pyramid. But before we start looking at the surface area, first I want to talk about what we're looking at on this page. Alright, so here we are looking at a hexagon. That's the base of our pyramid, and so this is a hexagonal pyramid. Now if I take my hexagonal pyramid and I tear it at the seams, so I tear it here or cut it, here, 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 and here, and open it up, then I'll get this figure. So this is called the net of our pyramid. Alright, so that is what the pyramid looks like. That is what it looks like when it's opened up. So if I'm asking you to find the surface area of our pyramid, then I'm actually just asking you to find the area of this shape. Now, if I'm asking you for the lateral area, all I'm looking for, if I say find the lateral area, is the area of all the triangles that come together to make our pyramid. So all the triangles, in this case 1, 2, 3, 4, 5, 6 triangles that come together to make our pyramid. So that is the lateral area versus the surface area. If I ask for the surface area, then I'm asking for the lateral area plus the area of the base as well. Alright, so now that you know what lateral area and surface area is, let's go ahead and talk about how to figure it out. Alright, so let's first focus on the triangles. I'm going to first focus on the triangle that we see the best, which is in the front. I'm going to outline it in red. If I wanted to find the area of this triangle, of one triangle, I would use the area of a triangle formula. And the area of a triangle formula is a half base times height. But since we're not just dealing with the triangle, we're actually dealing with the face of this figure, I'm going to go ahead and label the sides of my hexagon S, and I'm going to go ahead and label the slant height of my hexagonal pyramid. I'm going to call that slant height, actually let's put that going down here instead so we can see it. I'm going to call that L, and the reason I'm calling it L is because it is a slant height. So I know that this drawing looks a little bit confusing, so I'm going to take that triangle and I'm going to redraw it down here. So this is that front face I'm drawing. It's S is the base, and in blue I have L as the height. So really, the area of one triangle, that front face triangle, is going to be a half base, which is S, times our height, which is L. But there are 6 of those triangles, so I would have to go ahead and do half S times L 6 times. And I'm going to actually write this out, and you'll see why in just a second. Oh, can I get it to fit? Not so much. I'll go down here. A half, that's a plus sign, I promise. A half S times L plus a half S times L, and one more, a half S times L. And you're probably asking yourself right now, why would I go ahead and write that out 6 times? Why not just write it out once and then multiply by 6? Well, the reason for that is because I wanted to show you, I wanted to make it absolutely clear that therefore the lateral area of this figure is a half L. So I'm factoring out the half and I'm factoring out the L because it's a common factor, but I'm choosing to not factor out the S's, and you'll see why in just a sec. So S plus S plus S, and how many of them are there? That's right, there are 6 of them, so 2 more here. All right, half L times, we have here 6 S's. Now what do those 6 S's represent on our figure? So if I was to take S and add it to 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 S, what am I finding? If you said I'm finding the perimeter, you are absolutely correct. So this is the magic of the situation. We just figured out the formula for the area of the lateral area of a pyramid. Any pyramid, be it a hexagonal pyramid, a square base pyramid, a pentagonal pyramid, it doesn't matter. In every single pyramid, lateral area, which I'll call L, is going to be equal to a half the slant length times the perimeter. And that is a formula that you should know and that you should be able to call upon whenever you need it. That is how you find the lateral area of a pyramid. And again, the lateral area is the triangles, the area of the triangles put together. All right, so then how do you find the surface area? Well, we're going to use the letter S for surface area. The surface area is found by, of course, adding the lateral area, which we already know is half LP, to the base area, which we're going to call B. And now it really depends on what that figure is. So if the base is a triangle, then you use half base times height. If the base is a rectangle, you use base times height. If the base is any other regular polygon, then you're going to have to use the area of a polygon formula, which you've learned hopefully before. All right, so let's do an example using these formulas. Okay, so here we're being asked to find the lateral area and the surface area of this figure. And this figure is a square base pyramid. So in order to figure out the lateral area, we now know that the lateral area is going to be equal to a half LP, where L is the slant length, so that length right here, and P is the perimeter of the base. So now that we know this, we can go ahead and just plug in, substitute into our formula. A half L, or slant length, is 6 times P. Well, we don't know P yet, but it's not so hard to find. 4, since it's a square base, 4, 4, and 4. So our perimeter is 16. So we go ahead and substitute 16 here. And now we can plug it into our calculator, and we get 48 inches squared. So that is my lateral area, but it's not my entire area, because remember that the entire surface area is going to be lateral area, so lateral area L for short, plus base area. Now we did just find the lateral area, so we don't have to do it again. But we now have to find the base area. And fortunately for us, this is just a square. And you know that the area of a square is base times height. So our base is 4 and our height is also 4. So that means that the surface area of this figure is going to be 64 inches squared. Now, if you had a harder example, the first part will always remain the same. The lateral area is just a half LP. But the bottom, if you had to figure out the area of a hexagon or an octagon or some other figure, then you'd have to use the area of a regular polygon formula. And that's the only way in which this can vary. All right, hope that helped.